Happy Tuesday evening. Double integration we did last time. Double integration over general. Yep. Remember, with the problem that would be extremely difficult to do in rectangular. So that's the motivation for changing to polar coordinates. All right, so let's say we have this region. So we're bounded by two polar functions, h1 of theta, h2 of theta, between two rays, theta equals alpha and theta equals beta. If f of r theta is continuous over this general polar region, then the double integral over the region of f of r theta dA would be the integral from alpha to beta of the integral from h1 to h2 of f r dr d theta. What is the most common mistake when integrating in polar? What do you think?
They forget that R?
Yep. Forget that dA is r dr d theta. So they drop the r. Don't be common. Normal's blind, don't be normal. Normal's broken. You know where that comes from, they're awesome. Oh, that's it for the prelims. Pushing the dang button to the next slide. It's not going anywhere. There we go. So we want to evaluate this integral over the disk x squared plus y squared less than or equal to 36. If you look at this, that integral is impossible to do in rectangular. X squared plus y squared for 3a. How do you do that? You won't be able to. Suppose you could argue to try to do a trig cell. But you'd have to do that one variable at a time. This is going to be, if it's doable, it's absolutely hideous. But I'm not convinced it's doable. So we're going to have to convert. Well, good, they told us it's a disk, so immediately you should think polar. First, describe the region in polar coordinates. Remember, polar coordinates is an ordered pair r theta.
they're equal to R unless they're equal to 6. And 0 unless they're equal to theta unless they're equal to 2 pi.
Technically, that is not how we describe D. But it actually does it, in terms of the after calculation, it doesn't make a difference. Technically speaking, that 2 pi is not included, because then you have the same point twice.
So less than 2 pi.
Technically, it's less than 2 pi, but in terms of the actual integration, it doesn't matter whether you write it as less than or less than or equal to. So I'm going to stick with less than or equal to. Just keep in mind that mathematically it's not. Write the integrand in polar notation. So how would you write x squared plus y squared with 3/2 as a polar expression?
R cubed.
Just r cubed.
And then times the R.
Now you write out dA. Until you get the hang of it, I would do it in that way. First, convert the integrand, then write r dr d theta, instead of trying to incorporate that r in. As we get better with it, I may start doing that. So we get r to the 4th dr d theta. And now here's how I typically tackle these types of problems once we convert. Look in the integrand. Is there a theta? Look in the bounds for r. Does r depend on theta? So do integration with respect to theta first. That's just the length of 0 to 2 pi, which is just 2 pi. So with 0 work, we just did half the problem. Or half the integral. Two pi over 5. And just be times 6 to the 5th, right? Because it's r to the 5 over 5 from 0 to 6. What is 6 to the 5th power?
7776.
Lucky sevens. Play the original Final Fantasy 7. You know that Easter egg. Now times 2. And there's your integral. area of the region that lies in the first quadrant between x squared plus y squared equals 36 and x squared minus 6x plus y squared equals 0. What's area? How do we find area of a region?
Double integral dA.
Double integral over d, or integral over d. dA. Now we just have to describe d. So the first curve was x squared plus y squared equal to 36. Second was x squared minus 6x plus y squared equal to 0. And they told us it was in the first quadrant, right? Okay. Oh yeah, I actually turned off the axes. Yeah, that's good. What's our region? Just technically look here. You agree?
only talking about the first quadrant. Yeah,
I mean, it has to be first quadrant,
right.
tell us.
It says in the code.
That's clearly the region. Now we get to describe it.
I love solving basic geometry problems with double integration.
I don't know if this would really be, oh, I guess it is geometry, isn't finding an area. But I wouldn't say it's basic, I mean, it's not basic shape.
I mean, it's just the quarter circle minus the semicircle.
Well, it's not just. That's true, that's a semicircle, but what kind of semicircle?
Like, what do you mean, what kind? The top half of a circle?
What's the radius? Where's the center?
Doesn't matter where the center is. Well, I guess you don't know that the center's at 3, 0. I mean,
In the long run, you're right, the center's not gonna matter. But the radius does. So I'll let you do geometry then. You can, simple geometry, okay, go ahead and do it, we'll do the double integral, and we can verify that you get the same thing. Actually, first, you're gonna have to work with us, and then you can verify that here and later. Let's start with the easy one. Theta.
0 to pi over 2.
Now for R.
Greater than 6 cosine theta, less than 6. Well, less than or equal to, greater than or equal to.
How did you get it?
You can turn the first equation, you have x squared plus y squared, you can just make that r squared, and you can simplify that down to r equals 6. The second one is a similar situation, but you'll end up with r minus 6 equals 0. Minus 6x equals 0. X is equal to r cosine theta, so you'll end up with r is equal to 6 cosine theta.
Do you get if you convert the second?
R is equal to 6 cosine theta, or, yeah.
Should get r squared minus 6r cosine theta equal to 0.
Can you not turn that into r is equal to 6 cosine theta? No, okay.
Yeah, I guess technically you could if you realize that r is not 0. Right? You back out the r. But really you shouldn't. For here, you're right, it is going to be 6 cosine theta. Now, how did you get those as your values?
Well, it has to be between those two functions. And as we can see on the board, the x squared minus 6x plus y squared equals 0 is
What has to be between those two
the
terms?
area, the region.
True. So how did you know that that 6 cosine theta is the lower bound for r and 6 is the upper bound?
Really, I just looked at the graph on the screen, if I'm being honest.
The way you looked at it may trip you up on other regions, that's why I'm asking. Right, so you can't do this any longer. Right, you can't look at a vertical distance because we're no longer in XY. We're in R theta. So you're looking at R being between two curves. And R is distance from the origin. What is the smallest distance from the origin of that region? That yellow curve. Right, you have to imagine now you have to draw a line that represents R from the origin, and you let it rotate from 0 to pi over 2, right? So it's going like this, and it rotates up from 0 to pi over 2. So as it's rotating from 0 to pi over 2, it'll start, the smallest value it'll hit is this yellow line, which is the x squared minus 6xy plus r plus y squared equals 0, which is r equals 6 cosine of theta. The largest it's going to hit is the blue line, which is r equals 6. All right, so that's how you're going to look at it now in polar. So if you stick with the vertical, that may trip you up on some more complicated regions. Right, does that make sense, how we're getting that?
Yeah.
Right, so it is similar, right? So first you let, okay, what is theta ranging from 0 to pi over 2? So now just imagine your radius rotating from 0 to pi over 2.
Okay.
The integrand was what? Not the differential, the integrand.
R.
From the original. So ignore the differential for right now. So what are we integrating? What's the function that we're integrating?
1.
1. Ooh. Convert 1 into polar. 1. Now you convert your differential, which is r dr d theta. And there's the setup. Right, now it's just a matter of evaluating this. Is there a theta in the integrand?
No.
Does r depend on theta? Yes, it does. The lower bound for r. Bummer. That means we can't cheat. That's a bummer. Integral or antiderivative of r squared over 2. And evaluate r squared from 6 cosine of theta to the 6, you should get 36 minus 36 cosine squared. Right? How can we simplify that?
Isn't that
Just sine squared?
36 sine squared?
36 sine squared. Yep. Factor out the 36.
I was going to say factor out
36 over 2. do you want to go about that?
Change it back to 1 minus cosine squared of theta and then use power reduction. That's the first time I've done it.
Power reduction on what?
Cosine squared of theta.
You can do that. Can't you also just do power reduction on something?
I don't remember I do that.
What's the reduction identity sign?
Notice here, it says 1 minus cosine 2 theta over 2.
It's the same thing both on all sides.
And sine is minus, cosine is plus. You should get the same thing regardless. Oh, that's easy. One is just going to integrate the pi over 2 minus antiderivative cosine of 2 theta. 1/2 what?
Sine theta. Negative.
What's the derivative of 1/2 sine theta?
Oh, I should have been, did I get a sign wrong? Positive, negative, wrong.
It's not negative, but it is sine of 2 theta, not sine of theta.
Oh, right. Sine 2 theta.
And so it does stay minus because the original is minus. And that will go from 0 to pi over 2. That's sexy. What's sine of pi? What's sine of 0? Oh, isn't that nice? That term evaluates out to 0. Now we're left with an area of 9 pi over 2 square units.
Geometry.
Geometry is just calculus.
Without any of the hard stuff.
I kind of missed how we got to 6 cosine theta in the yeah. All right. So R is below 6. I get that because the radius of that outer curve is just 6, but R is above 6 cosine theta. Where's that coming from?
Ooh, you're going to calculate right now.
Well,
You can tell from there that that was not the right one.
what's the right one?
The CAS version.
CAS. Okay.
You don't have the CAS.
Okay.
That's just that.
I'm used to being sad. So 6 cosine theta. Where does that come from?
So you agree it's going to the lower bound for the radius if you draw a radial line from the origin.
Yes.
So the lowest that's going to be on this graph in this region is yellow, right? So yellow to blue.
Yellow to blue.
As it rotates, that's the equation for the yellow.
Yes.
Write that into polar.
So the x squared plus y squared, that's just r squared, and then minus 6x, x can be converted by r cosine theta.
Okay. Extra.
So then this becomes r squared minus 6r cosine theta. Solve for r.
Okay.
R is either 0
Mhm.
or 6 cosine theta. Right?
All right.
But if r is 0, that's just the origin,
Yes.
which is clearly not a region.
All right.
So then you need 6 cosine theta.
Okay. So we're just taking our we're just taking our original thing and using our rules about converting rectangular to polar on that.
Well, it doesn't have to be rectangular polar, you can use both of them interchangeably.
Both of what? Both of
Rectangular polar or polar to rectangular.
or polar to rectangular, right?
Because that's how you get the x squared plus y squared is r
Right,
squared.
right. Use our conversion
You
rules.
use the conversion
Right.
factors.
And then just solve for r to get the low. Okay, I understand. Thank you.
Alright, so describing the region is always half the battle,
Yes.
or I guess 3/4 of the battle.
Okay, I see. Thank you.
Now, would you have been able to do that if you weren't allowed to look at a graph?
Well, yeah, you can build this on a, if you can recognize that what you're looking at is 2010 in this case, right? Yeah.
If you were to convert, so yes, clear, it's obvious they're both circles, even without looking at the graph. Like you can write that first equation in its circular form by completing the square. Like that's not an issue. How would you determine which is your lower bound? Which is your upper? The theta should be easy enough to figure out 0 to pi over 2 because it's first quadrant. But then finding the bounds for r, this is where technology has made our lives a lot easier. It would be doable. Once you have your two equations for r, just pick a random theta between 0 and pi over 2 and see which one's larger. Right? But it would probably take a significantly more amount of work, right? Significant more work than just using technology to get the plot. Back in my day, I didn't get this advantage. So I had to do all this mentally. It's not fun. I wrote the second exam, by the way. I don't remember how people it was in terms of the regions. I guess it is fair to warn you that it did feel like the majority of the questions were multiple integration questions. Just as a fair warning. That's purely RNG. That wasn't actually my choice. I actually stopped because it was like really one after another multiple integration. Like no, multivariate functions on here. I don't fix that.
RNG.
Random number generator.
No.
Or the RN gods. No, that's if you believe that Jesus is God. I'm sticking with the math gods of Riemann and Euler. And I guess you could consider Newton. I think he's a false god, but I'm not going to mention my nature god. It's not class appropriate. So it'll continue. Oh, look, they already gave us polar. That's nice. Ah, yeah, this one's. It's this one. First, we're going to plot that region. Then we'll find the area. Inside the curve r equals 1 to the right of 1 over 4 cosine theta. Since they already gave it to us in the form of r equals a function of theta, we can just use polar plot. First one, over 4, wasn't it? Yes, over 4. And the second one was 1. Did they did, okay, for minus 5 to the power of 2. And that is terrible, so I'm going to do this. Can you tell which is which?
I can make a reasonable guess that r equals 1 is the semicircle.
Yes. R equals 1 has to be the semicircle. R equals 1 is the circle of radius 1. If not, you can always just add the legends, right? This is going to be a terrible one to paste. So, I think what I'm going to do. Stop that. You don't need that much of it anyway. That's all we really need, right? Probably go further than that, but that's good. That's better. There's the plot. Inside of r equals 1 and to the right of r equals 1 minus 4 cosine of theta.
So we're looking for the signed area, right?
No,
No?
total area. Remember, double integral doesn't differentiate between, it doesn't count assigned area, it's always total area. So that's why it doesn't, when you want area, it's usually better to find the double integral. So we again have two choices. This one should be good, just like the last one. What's the region? It's number 1. Now we have to describe it.
Secant theta over 4 is less than or equal to r less than or equal to 1. 2, 1 equal to theta 1, 1 equal to minus 2.
If you did that, that would be that. Which is clearly not what we want.
Why is it that? If it's negative pi over 2, what's the, like the same bound that's up there?
So you want negative pi over 2 pi over 2.
Yeah.
Then that would be,
Oh, I see.
that whole thing.
And we don't want
Which
that.
is not that whole thing, right? That's not what we want. We want what? We want this. So here's what we have to kind of look at, right? There's the origin. So I'll try and get this. Bless you. That looks good enough. Right, those are the two thetas we're trying to find, right? Because that region would then be, if you draw a ray, theta 1, as it rotates, right, it's going to start theta 1, that ray will go up to theta 2. So now the question is, what are those two angles?
So the two angles that satisfy the equation are cosine of 1/4 is equal to theta. Or the two values of theta that satisfy are cosine of 1/4.
No. Okay. Cool. One of them I agree with. What is the domain? What is the range for inverse cosine? 0 to pi, which means your other angle would be other side quadrant 2, which is not the angle we're looking for. But I do agree one of them is going to be that angle, right? The inverse cosine of 1/4. That I agree with. Which angle is that one going to be? Theta 1 or theta 2? Theta 2. So it's theta 1.
No, negative. Magnitude is 2, but it's, are we looking for 2 pi minus?
Plus or minus are cosine of 1/4.
Negative
Negative,
inverse
okay,
cosine of
yeah.
1/4 would be the theta 1. Right. Everyone's clear on how we got that. Right, 'cause, as I said, this is the most difficult part of the problem. Now, because I don't feel like writing the inverse cosine of 1/4 every bloody time, it's going to represent it with psi. My favorite Greek letter. And we're looking for area inside that region, the area of that region. So area is that integral Those are the bounds. And then dA is r dr d theta. There is our setup. Now it's just a matter of evaluating it. Yes? That would be the integral of r from a quarter secant theta to 1. Integral of 1 from minus psi to psi is what?
Two psi.
2 times psi. What is the antiderivative of secant squared theta?
Tangent theta.
Tangent of theta. So here's what I'm going to do. There'll be tangent of theta from minus psi to psi. So tangent psi minus tangent of minus psi. Right? Oh, but wait a minute. Isn't tangent odd? Which means tangent of negative psi is negative tangent of psi. So this bit in here is actually 2 times tangent psi. And then if you put that 1/2 back through, there's what we get. But that's not good enough. Put psi back in. Right, so psi was the inverse cosine of a quarter, right? What is tangent going to be now? Right, well, we know that psi is going to be acute, so we can use right triangle trigonometry without much fuss. Psi was the inverse cosine of 1/4. What 2 sides of this right triangle do we know? So for simplification, bless you, thank you. Horizontal is the base, vertical called the height, and then obviously the other one's the hypotenuse. So which 2 sides do we know?
Horizontal and hypotenuse.
What was the horizontal?
1.
No. What was the horizontal? What did I call it?
Base.
Base and hypotenuse. What's the base?
1.
What's the hypotenuse?
4.
Why am I not drawing? Why is my pen not working? What's going on? Yep. One is oh God, it just crashed. Did it? Oh, okay. But why did that get all blurry all of a sudden? What the? What's going on? That was really weird. I was like, I had enough of your crap. All right, where was I? All right. What's the hypotenuse? What is that missing length then? What's the height? How'd you get it?
The 16 equals 1 squared plus height squared. Height squared is 16 minus 1. Or, excuse me, yeah, height squared is 16 minus 1. So, the square root of that is square root of 15.
Now, what is tangent? There's the area. Inverse cosine of 1/4 is not a number in terms of pi. Leave it. That integral is easy, right? Keep getting to that point. I know it's pain. I just want to write this as a polar integral before we. Could you evaluate this in rectangular? Yes. Is it going to be fun? Because it depends on your definition of fun. Would I enjoy it? No, because I'm lazy. I prefer the path of least resistance. So we are going to convert this to polar. And by the way, Harrison, how I could tell that was the wrong one from here.
Oh, okay.
That's the right one.
Okay. I'll work on that.
So they do color code it.
Yes.
Because that one you're not going to be able to do any kind of symbolic manipulation on. You're not going to be able to solve equations on that.
Okay.
It won't give you exact values.
Right.
So if you try to do this integral on that calculator, it's not going to give you that. It's going to give you the decimal approximation,
Right.
which is of course not what I'm looking for.
Yeah.
So that means you have to do every integral by hand, even though you don't have to.
All right. Then I'll work on that.
I would recommend
Yeah.
if you're able to return that.
Sure. Oh, I've had it, for a minute. So. Yeah.
But the CAS rating is like 160. I think that's 120.
Yeah, something like that.
So sadly, you're out $120.
Well, more than that if you count a lot of other stuff.
At least the book was free.
Yeah.
But you have to pay for the website. And here, I don't think for right now I'm going to plot the region. Let's see if you can figure it out just from what's given without having to plot.
think it's the quarter circle in quadrant 3 of radius 3, so um, 0 is less than or equal to r less than or equal to 3. Theta is negative pi less than or equal to theta less than or equal to I use negative, so negative pi over 2.
Confident.
Pretty confident.
So we're still in the do. So if that's right, I'm throwing you a ladder. A rope ladder. If it's wrong, I'll still throw you a rope ladder, but the handles will be on fire. So you escaping pain-free or very badly burned?
Find out.
So unless you want to take a stab at it.
I second the boundaries for R, but other than that, I don't have anything.
Again, half a rope ladder.
Could the balance for theta also be pi to the 3 pi over 2?
That is not incorrect. That could work. That's not how I'm going to do it. I'm going to go with what you just said, 5 to 3 pi. But that would work. So yeah, it's the quarter circle radius 3 in the third quadrant. How did you determine that?
Well, the balance for y is negative 3 to 0. And the balance for x well, I was pretty confident, negative square root 9 minus y squared was the semicircle radius 3 in quadrants 2 and 3. So if you combine both those bounds, it's just the part of quadrant 3.
A little more complicated. You can tell the quadrant immediately just from the bounds.
Just because it's all negative.
So if x and y go from negative to 0, which is immediately quadrant 3. Then, yeah, that square root is, if you look at that, x equals negative square root of 9 minus y squared. That's x squared plus y squared equals 9, which is the circle of radius 3. Now you get to convert the integrand.
R sine theta over r squared plus 1.
Now, what does the x dy become? So I'm just gonna write it this way. Good news. It's not data be data easy. Bad news. You're gonna be left with r squared over r squared plus 1. How would you do that? I just don't think that's too terrible. Let's have some fun. Step out real quick. Trying to evaluate that integral by hand. Here's my recommendation: do theta first.
Yeah, because this is is that plus one minus one, same term.
Okay.
Because that will end up equaling 0. So it's the same thing as this. And then you can pull out this answer minus one, or you can do r squared plus 1 divided by r squared plus 1 added integral minus this other integral. And you can see that's like a dr over here. There's r from 0 to 3. That goes over there, and then that's for the minus this integral, and then you get your dv. So that makes sense.
Is it 3 minus inverse tangent 3?
Have the opposite order. But inverse tangent 3 minus 3. If you integrate if you integrate sine, you should get 1. Right? And the integral from 0 to 3 of r squared over r squared plus 1. I'd have to do that by hand.
Integration by points.
Again, I wouldn't. Be long division. You're left with 1 plus something over r squared plus 1, right? That something's going to be a constant. Minus. One minus 1 over r squared plus 1 dr. Integral of 1 from 0 to 3 is just 3. What is the antiderivative of 1 over r squared plus 1?
Minus inverse tangent 1.
Are you giving me the minus because there's a minus?
Yeah.
Oh, yeah. So what I have on here is wrong. If you want to do it by hand as well. Oh wait, no. I'm sorry. That is negative. Right?
zero.
It is negative, it is negative. Sine theta from pi to 3 pi to 2 is negative 1. Antiderivative is negative cosine. Cosine of 3 pi to 2 is 0. Cosine of pi is negative 1. Get 0 minus negative 1, which is 1. Negative that. That's why the order flips.
Oh, yeah. Yeah, I'm missing that. I was trying to open up here. And then I told you to do not.
Yeah, so that negative, okay, that's
Because I put that it should be one instead of negative one.
And of course, yes, inverse tangent of 0 is 0. You get inverse tangent of 3 minus 3. So that looked hideous to do by hand, but it's actually very simple to do by hand. And it seems like everyone forgot partial fraction decomposition.
I didn't, but I knew you couldn't, like, you can't do anything with r squared plus 1.
So
So how are you going to do partial fraction?
the first step of partial fraction decomposition is make it proper. Which is why I did long division. R squared over R squared plus 1 is improper.
Why? Because they're the
Same degree. Make it proper. That is always step 1 in partial fraction decomposition. And then as you notice, look, you're left with 1 over R squared plus 1, which is a simple antiderivative. So never forget that step.
Because what I did was from r squared over r squared plus 1, it made it so that it's r squared plus 1 minus 1 over r squared plus 1. And you can separate the r squared.
You can do that too again.
That's not the fraction of it.
You can do that too. Yeah. R squared plus 1 minus 1 gives you the exact same thing. That's integration in poultry. Question?
Quick question. We're going back to count 1 and 2. Your Q to do division here was the same power, right? The R, okay, yeah, thank you.
I know it's not a rational function, so my first thought was try partial fraction decomposition.
Yes.
Right? You could do trig sum. Trig sum would work here.
Or integration by
That might be a little more difficult.
yeah, it's not convenient.
You would have to be R squared,
Okay.
which means dv is the 1 over R squared plus 1, which gives you the inverse tangent as v. And then what's du 2r? So when you do the v du, you get 2r inverse tangent as an antiderivative, as an integral, and that is not fun to do. Because that would require integration by parts, but the inverse tangent antiderivative also requires integration by parts. So you're doing integration by parts within integration by parts within integration by parts. So it could be done. It's just not going to be done.
I forgot that the difference, if you differentiate tangent negative 1 of r, that's just a form there.
It's 1 over R squared plus
Yeah,
1.
so I did r, I did u du, so r equal to tangent, and then put u equal to that.
Yeah, you did trig sum.
Yeah, I forgot the form. Okay.
That's what I said. You didn't have to split it. You could have just done trig sum right from the start.
Yeah, if you recognize it.
But I'd rather do partial fractions than trig sum. So that's why I tried that first. And it worked. Yeah, but unless you're told that you can't use an integration aid, you're going to be allowed to use a calculator.
So you're not gonna wanna, in a question like this, you're not gonna.
Depends, because I did put some questions on the exam that said you're not allowed to use
Okay.
integration aid.
So it'll be clear.
Because I'm testing both setup and do you remember how to integrate.
Yeah.
But I didn't do that for all of them, so some of them you can use a calculator.
If it's the right one.
You just have to read each question carefully. Any other questions? And so as a reminder, I will not be here on Thursday.
Is there like a video you'll be posting or something, or is that day just off?
For now, let's just say it all. I'll do triple integrals on Tuesday. Yeah, I'm just gonna do triple.
This Thursday? This coming?
This Thursday, no.
But the quiz will have to be done before.
Yeah, the quiz will have to be done before 5 o'clock. Alright, so that's what I'm gonna do. I'm just gonna do triple integrals on Tuesday instead.
Okay.
Just give you the day off.
Oh, cool, thank you. The day to study, the day to practice.
Sort of.
To practice
But
more.
now you don't get a day to practice triple integrals.
Wow,
Because I originally going to do triple integrals Thursday and then have Tuesday to review.
okay. Oh, all right, wow, it's always something. Yeah,
So, have a wonderful weekend.
you too.
See you in a week.